Hi, and welcome to our first lesson in Chapter 4 that focuses all on linear functions. These are our objectives today, and I just want to warn you that I have the sniffles, so please excuse any sniffling that you hear throughout the video. Alright, let's get started. And before we get into the practice problems, I just want to reiterate that linear functions and linear equations are used constantly for problems such as distance traveled at a constant speed. So there are a lot of applications for this. It's not just some random thing in algebra. Now, with linear functions, the definition of a linear function is that it is a straight line and it has to be a function. So each x value is paired with only one y value. Let's now move into identifying graphs and determining whether they are linear functions or not. So looking at these first two, you don't need to write anything down. I just want you to think as to whether these two represent linear functions. If you said that the first one is not a linear function, you are correct. Although it is a function, it is not linear because it is not obviously a straight line. As for the second graph, this is also not a linear function because although it is a straight line, it's not a function because each x value is paired with many y values. And in this case, there is only one x value, and that's paired with many different ranges. For your first set of practice problems, I want you to take these three graphs and determine whether they are linear functions and explain why in your notes. So go ahead and do that now. Pause the video if you need time to do so. Let's now move on to identifying linear functions by looking at order pairs in tables. So in some cases, you may not have the graph to simply look at and you just have their order pairs. So to determine if you have a linear function or not, there should be a constant change in x that corresponds to a constant change in y, meaning that the difference from one x value to the next must be the same, as well as one y value to the next. And both need to be constant, not just the x's, not just the y's, both. Okay? So you do want to check for each change, not just stop at the first one and assume that it's going to be -3 for the rest. So if you were to graph these order pairs, you can see that it does form a linear function. You have a line and you have a function at the same time. Now here you have an example of a nonlinear function. So even though the x values are changing at a constant rate, the y values do not. And so you have this parabola, which is obviously not a straight line. So the lesson here is that you must check for each change in x values and y values. This is your one and only practice problem for this section of the notes. I want you to go ahead and determine whether this satisfies a linear function. Make sure you show it in a table form and you explain why. Pause now if you need to. Our third way of identifying linear functions is by looking at their equations. So here we have the definition of linear equation. Go ahead and rewrite in your own words into your MathCap. And the key thing here is that, you want to make sure linear equations can be written in this form. Very important to write down. Let's now study ways in identifying linear equations. So just a reminder that standard form is ax plus by equals c, where a, b, and c are all real numbers. 0 is a real number, just a reminder. So first example, obviously standard form, a is 3, b is 2, c is 10. So anytime you can identify the values of a, b, and c, it's a linear equation. Second one, even though it's written with y and x on different sides, if you move x and y to the same side, you can get this equation. There's also another version. And a is 3, b is -1, c is -2. So as long as I have my a, b, c values, I have a linear equation. Last one. Again, get x and y on the same side, and you can get this equation, and you have a is 5, b is 1, and c is 0. Here are examples of nonlinear, so when x and y are multiplied, if either one have exponents, or if either one is in the denominator of a fraction. Alright, so now you're going to practice identifying linear equations. In your notes, I want you to determine if these two are linear equations, and if they are linear equations, I want you to rewrite it in standard form. If it's not a linear equation, make sure you explain why. So make sure you have that complete in your notes. Before moving on to the last section of our notes, which is graphing linear functions, I wanted to present you with your random image of today. So if you look closely, there is something weird about this image, and I want you in the form to explain what is strange about this image. And if you can't figure out why, look in this general vicinity. Alright, so explain that into the form. We will be reviewing how to graph functions using slope-intercept, but for now, what I want you to do is I want you to first rewrite these equations into standard form, and I want you to graph them by, again, choosing your own domain and having enough so that you can plot a good pattern. Have those two completed in your notes. Now I want to reiterate a couple important things about domain and range, because when we get into graphing, these are concepts that you sometimes forget about. So go ahead and read these two paragraphs on your own, and in your own words, go ahead and write down what it's essentially trying to tell you in that bottom section of your notes. Make sure you pause if you need to. And lastly, what I want you to do is take a moment to read this problem. Now, I don't want you to graph, I don't want you to write anything down in your notes, but I do want you to explain in the form what domain is restricted from this function. Again, given this situation and given that function, what domain must be restricted? In closing, I just want to say that I will be checking your notes when we come back from the weekend on Monday. Please make sure that you also fill out the form and answer the questions there. And please, please, please be on your best behavior with the sub. And I hope you have a great weekend. See you Monday.